Problem 824. A bullet of mass 10 grams is fired into an initially stationary block and comes to rest on the block. The block of mass 1 kilogram is subject to no horizontal external forces during the collision with the bullet. After the collision, the block is observed to move at a speed of 5 meters per second. First, find the initial speed of the bullet, and second, find how much kinetic energy is lost. Okay. Well, let me draw an overview here. In overview, we have a mass m1, velocity v1 of a bullet, and the block m2 has no velocity. It's at rest, and then finally we have one object formed together, the bullet and the block, which has some final velocity v prime, final configuration. The context of the problem indicates that momentum is conserved. Only the internal force of the bullet of the block and the block on the bullet are there, and therefore momentum will be conserved. And so the initial momentum is the momentum of the bullet, and the final momentum is the momentum of the block and the bullet as a unit. One can then solve this equation for v1, the initial velocity of the bullet. So v1 is equal to m1 plus m2 v prime divided by m1. Okay, so the mass of the bullet and the block together are 1.01 kilograms, 10 grams being 0.01 kilograms, times the velocity after the collision of the mass and the bullet, which is observed to be 5 meters per second. And then the velocity of the bullet, 10 grams, 0.01 kgs, divides, and the result is 505 meters per second. So how much kinetic energy is lost? Well, the change in kinetic energy is equal to the final minus the initial, and so that's going to be the final kinetic energy is going to be equal to 1/2 times the mass of the block and the bullet times the velocity of the mass and the block and the bullet squared, and the initial kinetic energy is going to be the 1/2 times the mass of the bullet times the velocity of the bullet squared. Well, we just found what the velocity of the bullet was up there, 505 meters per second squared. And so this comes out to be minus 1.26 times 10 to the third joules, or in other words, minus 1.26 kilojoules. Remember, that's equal to, K means times 10 to the third. And negative means it's lost. It means that the final is less than the initial. Where does that energy go? It goes into heat.